Okay, so here we go, graphing an absolute value function. So you look at the function, what type is it? It's an absolute value function. So you go to your notes and you check out what the rules tell you is going on. So this plus 2 on the inside of the absolute values says that you're going to go to the left 2 units. So I know the whole function is going to shift left 2. Then we have this minus 3 on the outside. When it's on the outside, it says to move that down. When you add or subtract on the outside, it goes the direction it tells you to go. When you add or subtract on the inside, it goes opposite that. So the next thing I look at is the absolute value parent function. Now I'm going to graph the parent function here, but this is not the answer. So the vertex is at the origin, and then it goes up 1 and over 1 in both directions. So this is the absolute value parent function. It is not the answer, so you don't have to graph this every time you do one of these problems. You just have to graph the result of changing this. So where's this going to change? It's going to change. It's going to go left 2 and down 3. So I start with the vertex. I'm going to move that vertex. I'm going to move it left 2 and down 3. And then from there, this is my new vertex. From that new vertex, I look at the parent function and I ask myself, what do I need to do to get to the next dots? So I have to go up 1 and right 1, up 1 and left 1. That's going to get this pair of dots. So up 1, right 1, up 1, left 1. There we go. To get to the next pair of dots, go up another one and right another one, up another one, left another one. So that's the pattern that this follows. Just up 1, over 1 every time. And then you draw your graph. There you go. Okay, again, the green line you don't need to draw. That's the parent function that the new line is based on. Okay, let's try another one. So let's move over here. The plus 2 on the inside, whenever it's on the inside, it goes backwards. So it doesn't go to the right, it goes to the left. So this is going to make it move left 2. The plus 4 on the outside is going to make it go up 4. And then this minus 2 in front is going to do 2 things. The negative is going to flip it upside down. And the 2 is going to stretch the y by a factor of 2. So every time you go up, it's going to go up twice as much. Okay, so our parent function is the same as that green graph on the one to the left, but the vertex is going to shift. It's going to go left 2 and up 4. So left 2, up 4. I'm going to put my new vertex. Now it got flipped upside down. So if there was no stretch, it would just go down 1 and over 1, down 1 over 1, and there you go. But since there is a stretch, it goes down twice as many as normal. So instead of going down 1, it's going down 2. Still going over 1. So down 2 over 1, down 2 over 1, and that's going to continue. Down 2 over 1, down 2 over 1. So when there's a stretch, the y just gets multiplied by that number. Okay, so those were absolute value functions. Now we're looking at quadratics. So notice the change. You've got a square on the parentheses, and that's how I know it's going to be a quadratic. So now the parent function changed. So the parent function for a quadratic, the vertex is at 0, 0. And again, this should be in your notes from the previous videos. And then it goes up 1 and over 1. And then from here it goes up 3 and over 1. So up 3 and over 1. So that's the parent function for any quadratic. And again, you don't need to graph this in your answers, but all of your answers will be based off of this parent function. Okay, so then where will we move? What's going to change? Let's go back and look at our graph, or our equation. So that minus 1 is on the inside of the parentheses, inside moves left and right. And when it's negative, it's going to move it to the right. So I want you to write down every time what you're doing to the function, just like I'm doing here. So it moves right 1, and then this minus 4 is outside, so it's going to go down 4. So I want you to write that down every time. Write 1, down 4. Okay, so the vertex point is going to do just that. It's going to move to the right 1 and down 4. It's going to end up down there. Then to get to the next pair of points, what does the pattern tell us to do? So you look back at the parent function, that tells you your pattern. So from the vertex, it went up 1 and right 1. So up 1, right 1. The other point went up 1 and left 1. So there we go. I'm just following this pattern. Then it goes up 1, 2, 3, and then right 1. So up 1, 2, 3, right 1, and then it goes up 1, 2, 3, and left 1. So 1, 2, 3, left 1. So there we have our new graph. Okay, it's the exact same shape as the green one, but it's just moved. Okay, so that's how we would graph that one. All right, let's take a look at this one. Again, it's a quadratic, so it's going to be the same parent function as that previous one. This plus 1 tells me to go to the left 1 inside, so it goes left and right, positive goes left. And this plus 3 tells me to go up 3. And don't forget about this negative in the front. So that negative in the front is going to flip it upside down. Okay, and really the flip occurs first. So if you can imagine this green graph over here, if you can imagine this flipping upside down initially, and then you do the shift, that's really what happens. But I think most people find it easier just to move the vertex left 1 and up 3, and then flip it over from there. So it's going to flip upside down, and so instead of going up 1 and over 1, go down 1 and over 1. So down 1 over 1 in both directions, and then down 3, 1, 2, 3, and over 1 in both directions. And there we have our graph. Okay, so there's an assignment posted. Complete the 8 graphs, and buying some graph paper will make this a whole lot easier for you. So I would highly recommend that. If you have questions, make sure you ask them.